Let's explore the fundamental concept of inheritance within object-oriented programming. Previously, we looked at how objects interact, but when we need to describe a specific type of classification, we use what is called the is-a relationship. Consider the players in a chess game. A player might be a human, such as Gary Kasparov, or they could be a piece of software, such as Deep Blue. In programming, saying Gary Kasparov is a player is formed by inheritance. Inheritance functions similarly to a biological family tree. Just as an individual might inherit traits like eye color from a parent, a class in programming can inherit attributes and methods from another class. This lets us define a general category and create specific versions without starting from scratch. To see this in action, let's look at modeling chess pieces. While there are 32 physical pieces, they fall into 6 categories. Every single piece shares certain commonalities like having a color and belonging to a specific chess set. Instead of defining these traits 6 different times, we use a base class called piece to hold these commonalities. Looking at our inheritance diagram, you can see the base class labeled piece right here at the center. Inside it, we have those shared internal details like chess set and color. Radiating outward are the specific types of pieces like the rook. Notice the lines connecting these boxes to the central piece class ending in a hollow arrow. This signifies inheritance, meaning every subtype automatically gets the traits defined in the base class. But each subclass also provides its own specific version of its shape and how it moves. This brings us to a powerful mechanism called method overriding. If we have a generic piece, the board needs to know how to move it. We can implement a default or dummy move method in the base class. But when we create subclasses, we override the default method with specific logic like telling a rook to move horizontally. This concept applies to our player example too. A basic player might just pick a random move, but a more advanced subclass like Deep Blue would override that same method with complex algorithms to challenge a grandmaster. Now, in chess, a default generic move doesn't make much sense. Instead, we use abstract classes and interfaces. An abstract method means we decline to provide a default implementation and instead force the subclasses to provide it. Because of this, you cannot create a generic piece object directly, you can only create specific pieces. Taking it further, an interface acts as a strict blueprint or contract that has no implementation at all, only defining what a class must do. To summarize, inheritance allows us to build a hierarchy where general traits are defined once and specific behaviors are tailored in subclasses, ensuring our code is organized, reusable, and highly logical.